So today we are going to discuss linear combinations. But first of all, let us discuss how to, what are the linear systems as linear combinations? How can we write linear systems as linear combinations? In fact, this concept also helps us to discuss about the solutions of a linear system. For example, if we have a linear system of this kind, x1 plus x2 plus 2x3 is equal to 9, and 2x1 plus 4x2 minus 3x3 is equal to 1. This is an example on the slide number 21 of the lecture slides 6. 3x1 plus 6x2 minus x3 is equal to 0. So this is the given linear system. Earlier, we have written this linear system in the matrix form. So we can write this thing as AX is equal to B. I hope you know how to write it. But now we are going to write it in a different way. Can I write this thing as 1, 2, 3 times x1 plus 1, the coefficient is 1 here, coefficient is 1 here. So 1, 4, 6 times x2 plus here the coefficient of x3 are 2, -3, -5 times x3 is equal to 9, 1, 0. Okay. Can I write this linear system in this way, where the first column vector or the coefficient, the first column vector and times x1 is basically this thing in the linear system. It basically, we write every coefficient of x1 in the form of a vector times x1. Similarly, x2 times the coefficient of x2 in every term, in every equation, the coefficient of x2 we have written in the form of a vector. And similarly, x3 is equal to the right-hand side vector. Now, if we say that this is a vector v1, okay, this is a vector v2, and this is a vector v3, and this is the vector b, the right-hand side vector. Now, how can we write now this expression? We can write it G, yes? Any question? Okay, v1 vector x1 plus v2 vector x2 plus v3 vector x3 is equal to b vector. I hope you get it, how I have written this linear system in this form first and then in this form. Now we say that B is a linear combination of the vectors v1, v2, and v3. Okay. So this is what B is, a linear combination of the vectors v1, v2, v3. Where, notice that, where x1, x2, and x3 are coefficients and x1, x2, and x3, they belongs to some real number. They are real numbers here. They can be complex number, but we'll discuss them later on. But these are real numbers. These are some constants, x1, x2, x3. They are now constant. They are no more vectors. Okay. here in this case, when we had written this linear system in this matrix form, here A was a coefficient matrix, X was a vector. X is what? X was a X1, X2, and X3. It was a vector. Now, in this linear combination thing, X1, X2, X3, they are no more vectors. They are components of that vector. They are individually real numbers. Okay. Now the vectors are V1, V2, V3, which are basically the coefficients of X1 in this linear system. So you have to differentiate between these two things. Don't be or don't mix up X1, X2, X3 with the X. Now X1, X2, X3 are real numbers, and V1, V2, V3 are the vectors. Now we say that B is a linear combination of the vectors V1, V2, V3. Okay. This is how we can write linear systems as a linear combination of vectors. Furthermore, this thing can be written in the form let me in a matrix or in vector form in this way: V1 vector, V2 vector. Sorry, not this one. Okay. V3 vector times X1, X2, X3, okay, is equal to B vector. Okay. Therefore, every linear system can be written as a linear combination of the vectors. Similarly, I have another example on the page 22, on the very next page, on the same slides, lecture 6 slides. On slide 22, you can see another example of a linear system which we can write as a linear combination of the coefficients of X1 and X2 and so on. Okay. Now let's write the formal definition of a linear system. If W is a vector in R, N. Remember one thing in a linear combination, V1 X1 plus V2 X2 plus V3 X3 is equal to B. Now, we say that B is a linear combination of V1, V2, V3, provided that there exists, okay, we say that B is a linear combination of V1, V2, V3, provided that, अब इस पे एक addition हमने एक condition लगा रहे हैं, provided that there exists value at least, there exists at least one solution, of that linear system, because this is actually what we have written. This is a linear system. Then there exists at least one solution of the linear system. Okay, means we must have the values of x1, x2, and x3 for which this equation is true. Okay, that is, we have values of x1, x2, and x3 for which the equation 1, for example, this is equation 1, okay, for which the equation 1 is true. Is true means there must exist some x1, x2, x3, so that when we multiply x1 with v1, x2 with v2, x3 with v3, and solve it, we should get the same vector as v. So I hope you understand. We have the values of x1, x2, x3 for which this equation is true. Now, what are the unknowns only? In this equation, what are unknowns? The unknowns are x1, x2, and x3. So we have to find the values of x1, x2, x3 for which this equation is true. Okay. So for that, what we have to do, in fact, we have to solve this linear system because this is a linear system now. If you have any question, you can ask me. And I hope you know how to solve a linear system. You can use Gaussian elimination method or Gauss-Jordan elimination method. You can use echelon forms, reduced echelon forms, and so on. Now, formally, what is the definition of a linear combination of vectors? This is the definition. You can read it from the lecture slides, number 16. Okay, from lecture slides are already been uploaded to LMS. If W is a vector in Rn, okay, I'm going to write it very briefly. If W is some vector in Rn. Now, I hope you know what is Rn. Then, yeah, chale, और कर लें, एक और कर लें. हाँ. And we have another set, and we have a set of vectors v1, v2, so on, vn. Okay. This set is basically a subset of Rn. Means these are n vectors in Rn. We have chosen some other vectors from Rn. Then we say that or the W is called, then W is said to be linear combination of the vectors v1, v2, so on, vn. If W can be expressed as W is equal to K1 V1 plus K2 V2 plus so on plus Kn Vn. Okay, where Kn, K1, K2, so on Kn, these are constants, where K1, K2, so on Kn, these are real constants, or you can say them these are scalars. Okay, these scalars are coefficient of the linear combination. So if such kind of constants exist, K1, K2, K3, so on Kn, if we can find these constants for which this equation is valid, for which this equation becomes true. Now, W and V, these vectors V1, V2, so on Vn, they will be given. And we have to check whether we can write W as a linear combination of V1, V2, so on Vn. Then what we do, we write this kind of expression. Now, what is this expression? This expression is in fact a non-homogeneous linear system, as we have written on the previous boards. Here, this expression is same as the linear combination. Okay, I have told you. Now, what is this? if we compare these two expressions, these two equations, this is your W, which I have written in the definition. This is what? This is your W, okay? And V1, V2, so on, V3, they are same as V1, V2, V3. And X1, instead of X1, I have written K1, K2, and K3, okay? Now, in fact, we use this definition of linear combination in order to discuss the solutions of a linear system. But we have to define this definition more generally so that it can be used in other concepts of mathematics or in other topics of mathematics as well. So instead of writing here x1, x2, x3, I can write k1, k2, k3. Then this linear system will become basically 1, k1, k2, k3, k1, k2, k3, k1, k2, k3. So this is still a linear system, okay? I hope you get it. If you have any question, you can ask. So if you want to know whether we can write any particular vector as a linear combination of some other vectors, what we do, we write this expression, this linear system, and solve for it. Okay, we'll solve for it, solve this linear system, and find the values of k1, k2, so on, kn. Okay, if these values, if the values of k1, k2, kn exist, for which this linear system, non-homogeneous linear system, is true, that the left equation, left-hand side is equal to right-hand side, or by simplifying the right-hand side, we get W again, then we say that W is a linear combination of V1, V2, so on, Vn. I hope you get it. If you have any question, you can ask me. Let's do an example of GGG beta.
हमें कैसे पता this is non-homogeneous and W is not a zero vector?
W can be any vector. If W is 0, then we'll discuss this special case later on. Let me discuss this thing first, okay? If W is 0, then we'll have homogeneous linear system, okay? If we have homogeneous linear system, then what will happen? Then there are several cases. If we have homogeneous linear system, then this homogeneous linear system can have trivial solution or non-trivial solution. If this homogeneous linear system has only a trivial solution, what would be the trivial solution? Tell me. Who asked me the question?
So it would be 0, 0, or unique solution, which would be 0, 0, I think.
0, zeros are the values of what?
K.
K's. So in that case, K1 is 0, K2 is 0, and so on, N is 0. Okay?
Yeah.
Okay. Remember this. I'll come back to this point. बल्कि चले मैं बता ही देता हूँ. Let me use the other board. If we have 0 on the W is 0, then we have K1 V1, K1 V1 plus K2 V2 plus so on plus Kn Vn. Okay. Now there are two possibilities. Okay. Then the case one. Okay. If W is 0, if W is a 0 vector, case 1. Case 1 means this homogeneous linear system, this is 2, okay? This homogeneous linear system has a trivial solution. Trivial solution. What does it mean? It means that K1 is 0, K2 is 0, and K so on, Kn is 0. In this case, we say that the vectors v1, v2, so on, vn are linearly independent. Linearly independent. Okay? And the case two, this homogeneous linear system has infinite many solutions. Infinite many solutions means at least one of k's are not zero.
सर
Okay? Easy.
सर इस बोर्ड को थोड़ा जूम आउट कर दें, सही तरह नजर नहीं आ रहा.
Okay. Sorry. This one. Is it okay now?
Yes sir.
Okay. Now, in the case of linear combination, we were discussing linear combinations. How can we write a vector as a linear combination of other vectors? This is basically a manipulation of linear systems. We write linear systems differently. Right inside of the linear system as a linear combination of the coefficients of x1, x2, so on, xn. Then if that linear system has a solution, then we say that W can be written as a linear combination of the V1, V2, so on, Vn. Now, if the right hand side is vector is 0, and we obtain a homogeneous linear system, if that, then we have two cases. First case is if this homogeneous linear system has only the zero solution or the trivial solution, means K1, K2, so on, Kn, they are all zero, then we say that these vectors V1, V2, so on, Vn, they are linearly independent. They cannot be connected with each other. They are, let me discuss that case. Now the case 2 is if the homogeneous linear system has non-trivial solutions. Okay? Non-trivial solutions. That is, all k's, all you can say all the values of k1, k2, so on, kn are not zero, are not equal to zero. Means आपका जो k की वैल्यू होगी सारों में से कुछ जीरो हो सकती हैं, कुछ नॉन जीरो हो सकती हैं, ठीक है. What does that mean? For example, if we have two vectors, पहले हम इसकी example discuss करते हैं, then we'll come back to that case. If we have three vectors, v1, v2, v3, okay, this one, and we have and we write 0 is equal to k1 v1 plus k2 v2 plus k3 v3, and this is homogeneous linear system, and we say that this homogeneous linear system has no trivial solution. Means you can say that k1 is maybe something -2, k2 is 0, and k3 is maybe 5. Okay, at least one of the k is non-zero. Then what will happen? If we insert the values of k1, k2, k3 here, we can have -2 v1 plus 0 plus 5 v3. Okay, this one, vectors. Now, what does this mean? It means that v1 is equal to 5 by 2 v3. Mic off kar le kindly. Now, what does this mean? V1, the vector V1 is a constant multiple of vector 3, V3. किसी का mic on है, kindly mic off कर लें. What does this mean? V1 depends on V3. Okay, in that case, we say that these vectors are not linearly independent. यार ये कौन है? इसको कहें माइक ऑफ करे. Who's this guy? So let me resume the recording. No, recording has been resumed. Okay. Now, what happens when this homogeneous linear system has non-trivial solutions? So non-trivial solutions of the homogeneous linear system tells us that these vectors are not independent, or not linearly independent. Then we call them, then we say that the vectors V1, V2, V3, or the set of these vectors, or this set of vector is linearly dependent set. Okay. What does it mean? Means that the vectors in this set, they depend on each other. They're not linearly independent. I hope you get it. If you have any further question, who asked me this question? Some girl was asking this question. You got this now? So
Yes,
basically, the concept of linear independence and dependence is connected with the concept of linear combination of linear systems. Okay, this is how we can write linear combinations for if we are given some linear system. And what does this mean, linear combinations? It's basically that the linear systems have solutions. If they have unique solution, then be at least one solution, not only unique solution, at least one solution, then we can say that W is a linear combination of the vectors V1, V2, so on, Vn. Okay. Similarly, the right-hand side vector, if it is 0, then the concept of linear independence and dependence comes into in. Yes, जी बेटा बोले.
सर मतलब अगर हम डिटर्मिनेंट ले लें सिर्फ और वो 0 के इक्वल आ जाए, हम ये नहीं कह सकते कि ये लीनियरली डिपेंडेंट है.
हाँ, अब आपके क्वेश्चन की तरफ आते हैं जो आपने ही पहले क्वेश्चन पूछा था, वो डिटर्मिनेंट वाला, linear independent वाला. किसने पूछा था?
नहीं सर, वो और कोई था.
चलें, let me explain. You'll also understand. Now, अब हमने क्या मेक श्योर करना है कि किसी भी लीनियर सिस्टम में अगर किसी लीनियर सिस्टम का यूनिक सॉल्यूशन है, ठीक है, चाहे वो होमोजेनियस लीनियर सिस्टम हो या नॉन होमोजेनियस लीनियर सिस्टम, ठीक है. लीनियर कॉम्बिनेशन की फॉर्म में कब लिखा जाएगा? जब उसका जो कोएफिशिएंट मैट्रिक्स होगा उसका डिटर्मिनेंट नॉन जीरो होगा, ठीक है. इट मींस अगर कोएफिशिएंट मैट्रिक्स का डिटर्मिनेंट नॉन जीरो है तो लीनियर सिस्टम का सॉल्यूशन क्या होगा? यूनिक होगा, ठीक है. अगर यूनिक होगा लीनियर सिस्टम का सॉल्यूशन तो K1, K2, Kn की वैल्यूज एग्जिस्ट करेंगी, ठीक है. यहां पे हमने ये लीनियर सिस्टम लिखा था. अगर इसका सॉल्यूशन एग्जिस्ट करता है तो सॉल्यूशन कब एग्जिस्ट करेगा? जब इसका कोएफिशिएंट मैट्रिक्स इस लीनियर सिस्टम का अगर उसका डिटर्मिनेंट नॉन जीरो है तो इसका यूनिक सॉल्यूशन आएगा. यूनिक सॉल्यूशन आएगा मींस K1, K2, सो ऑन Kn की कोई एक यूनिक वैल्यूज आएंगी नॉन जीरो, क्योंकि नॉन होमोजेनियस लीनियर सिस्टम है. What we say then, we say that W can be written as a linear combination of this thing, ठीक है. अच्छा, दूसरी बात, जब इसका सॉल्यूशन यूनिक होगा तो डेफिनेटली कोएफिशिएंट मैट्रिक्स का जो डिटर्मिनेंट होगा इस लीनियर सिस्टम का, ए मैट्रिक्स जो हमने ऊपर लिखा था यहाँ पे, इस लीनियर सिस्टम का जो कोएफिशिएंट मैट्रिक्स होगा ये नॉन सिंगुलर होगा. नॉन सिंगुलर होगा मींस इन्वर्टेबल होगा, इसका डिटर्मिनेंट नॉन जीरो होगा। ठीक है, तो अगर ये चेक करना है हमने कि इस वेक्टर को एज अ लीनियर कॉम्बिनेशन ऑफ दीज वेक्टर्स हम लिख सकते हैं या नहीं, if we are only being asked to whether check we can write or not, then you have to check whether this coefficient matrix is invertible, its determinant is non-zero. Then we can say that B can be written as a linear combination of vectors of these vectors which are the coefficients of x1 and x2 and x3 in the linear system. Now let's come back to homogeneous linear systems. होमोजेनस लीनियर सिस्टम्स में अगर ये आपका होमोजेनस लीनियर सिस्टम है, अगर इसका यूनिक सॉल्यूशन हो, यूनिक सॉल्यूशन मींस ट्रिवियल सॉल्यूशन ही होगा। ठीक है, किसी भी नॉन होमोजेनस होमोजेनस लीनियर सिस्टम का ट्रिवियल सॉल्यूशन अगर एग्जिस्ट करता है, सिर्फ ट्रिवियल सॉल्यूशन, तो वो मस्ट है कि वो जीरो हो। नॉन जीरो यूनिक सॉल्यूशन होमोजेनस लीनियर सिस्टम का एग्जिस्ट नहीं कर सकता। अगर यूनिक सॉल्यूशन एग्जिस्ट करता है तो वो इट इज मैंडेटरी कि वो जीरो सॉल्यूशन ही होगा। तो इन दैट केस अगर जीरो सॉल्यूशन एग्जिस्ट करता है इसका, तो देन वी से दैट दीज वेक्टर्स आर लीनियरली इंडिपेंडेंट, दे आर नॉट कनेक्टेड विद ईच अदर। ठीक है, अगर आपके पास डिटर्मिनेंट जीरो है फॉर एग्जांपल, इवन देन होमोजेनस लीनियर सिस्टम के आपके पास इनफिनिट मेनी सॉल्यूशंस आएंगे, और नॉन होमोजेनस लीनियर सिस्टम के भी इनफिनिट मेनी सॉल्यूशंस आएंगे। ठीक है, k की वैल्यूज इनफिनिट मेनी होंगी। इन दैट केस इवन डिटर्मिनेंट इज स्टिल जीरो, बट the linear system has solution. Even then we can write B as a linear combination of the vectors v1 v2 so on vn. Similarly अगर यहां पे डिटर्मिनेंट जीरो है होमोजेनस लीनियर सिस्टम में, तो फिर ये लीनियरली इंडिपेंडेंट वेक्टर्स नहीं होंगे, उसमें केस की वैल्यूज नॉन जीरो भी होंगी और जीरो भी हो सकती हैं, सारी नॉन जीरो भी हो सकती हैं। ठीक है, फॉर एग्जांपल अगर आपके पास k1 की वैल्यू ये, k2 की, k3 की, जरूरी नहीं है k2 की जीरो, इट कैन आल्सो बी नॉन जीरो। इन दैट केस यू कैन हैव दैट 9v2, और यहां पे आपके पास फिर क्या आ जाएगा, प्लस 9/2v2. In that case, v1 is a linear combination of, now in that case, v1 is a linear combination of v2 and v3. Okay? It means if the vectors are linearly dependent, then we can write any vector of that set as a linear combination of other vectors. Okay? अब यहां पे आप v1 को एज ए लीनियर कॉम्बिनेशन ऑफ v2 v3 लिख सकते हैं, v2 को एज ए लीनियर कॉम्बिनेशन ऑफ v1 एंड v3 लिख सकते हैं, v3 को एज ए लीनियर कॉम्बिनेशन ऑफ v1 एंड v2 लिख सकते हैं। ठीक है, सो दिस इज वेरी इंपॉर्टेंट रिजल्ट इन व्हिच वी आर बेसिकली विल डिस्कस लेटर ऑन। बल्कि अभी लिख लें, बाद में क्या लिखना है।
सर जब नो सॉल्यूशन होगा फिर क्या होगा?
नो सॉल्यूशन क्या मतलब? होमोजेनस लीनियर सिस्टम में तो सॉल्यूशन होगा ही होगा, क्योंकि होमोजेनस लीनियर सिस्टम्स आर कंसिस्टेंट लीनियर सिस्टम्स। ठीक है, लेकिन अगर आपके पास नॉन होमोजेनस लीनियर सिस्टम है, इन दैट केस इफ द सॉल्यूशन डज नॉट एग्जिस्ट, व्हाट डज इट मीन? वी कैनॉट राइट B as a linear combination of vectors v1 v2 and v3. This is what we obtain as a result.
सही हो गया सर।
You got it?
Yes,
If
sir.
there is no solution of the non-homogeneous linear system, then we say that B cannot be written as a linear combination of vectors v1, v2, so on, vn. Okay. Any other question? So if this set is linearly dependent, then a very important result, then we can write any vector in the set v1 v2 so on vn. अगर आपके पास n vectors हैं, any vector in the set this as a linear combinations of other vectors or the remaining vectors. Okay. As I have explained you here in this example, if this homogeneous linear system has non-trivial solution, okay, then we can write any one of these vectors as a linear combination of the remaining other two vectors. Okay, so this is. I hope you get it. If you have any question, you can ask me.
The only time we can't write a linear combination of vectors is when non-homogeneous linear systems have no solution.
Yes. Can you repeat?
I'm
थोड़ा सा
saying
ऊंचा बोल.
the only time we cannot write a linear combination of vectors is when non-homogeneous linear systems have no solutions. Otherwise, we always can.
Yes. But in case of homogeneous linear system, the two new concepts basically originates: linear dependence and linear independence of vectors. Okay.
In both
Now,
cases, we can write it right.
yes. So when we have to check whether these three vectors or any n vectors, whenever we have to check, how to check that whether the set of vectors means V1, it contains V1, V2, so on, Vn, is linearly independent or dependent. How can we check now, after all this discussion, how can you check whether this set is a linearly dependent or independent? Anyone?
When the determinant is not zero. When the determinant of our system is not zero.
Well, it is.
It has several methods. Okay? The first method, okay, how can we check? We will write a homogeneous linear system by taking these vectors. Okay, homogeneous linear system कैसे लिख सकते हैं? By using these vectors. We consider what? Yeah, we write a homogeneous linear system as, ठीक है, homogeneous linear system कैसे लिखेंगे इसको? या linear combination लिखें इसका, ठीक है? We can say homogeneous linear system, या आप कह सकते हैं कि इसका इन vectors का linear combination लिखें. Linear combination कैसे लिखेंगे हम? Some constant k1 v1 plus some other constant k2 v2 plus so on plus kn vn equal to 0. So this is what, ये इनका linear combination है, और हमने अगर इसको equal to 0 put किया तो क्या होगा? ये homogeneous linear system बन जाएगा. ठीक है? Now if this homogeneous linear system has trivial solution, if we call it system 3, if homogeneous linear system 3 has only trivial solution, that is what? All the k's are 0. Kn is equal to 0. अगर इसका सिर्फ और सिर्फ trivial solution है, then we say that what? Then we say that the set v1, v2, so on, vn is linearly independent. Okay? Achha, what is equivalent to this? If we can put these vectors in the form of a matrix, okay, equivalently or equivalently, अगर हम ये कहें कि if we put all these vectors in a matrix form, v1, v2, so on, vn. Okay, this is a matrix. क्यों क्यों मैट्रिक्स है? क्योंकि v1 जो वेक्टर है वो एक कॉलम वेक्टर है, इसके n कंपोनेंट्स हैं, और कितने वेक्टर्स हैं? n वेक्टर्स हैं. तो ये मैट्रिक्स बेसिकली इसका ऑर्डर क्या होगा? n क्रॉस n ऑर्डर का ये मैट्रिक्स है, क्योंकि v1 इज अ वेक्टर. अभी हमने वहां पे v1 लिखा था जब होमोजेनस लीनियर सिस्टम में. लेट मी गो बैक टू दैट लीनियर सिस्टम. यहां पे देखें, यहां पे आपके पास v1 क्या है? v1 इज अ वेक्टर. ठीक है, अगर आप इस वेक्टर को, इफ यू पुट दैट वेक्टर इन अ मैट्रिक्स हियर, व्हाट डू यू ऑब्टेन हियर? इस वेक्टर को हम कह रहे हैं कि ए मैट्रिक्स है जो कि v1 वेक्टर है, v2 वेक्टर और v3 वेक्टर. ठीक है, अगर हम वेक्टर की वैल्यूज पुट करें इस वेक्टर की, तो ये क्या है? 1 2 3. So 1 2 3, and the other v2's vector is 1 4 6, and v3 vector is 2 -3 -5. So this matrix is a 3 cross 3 matrix. Okay, I hope you get it. Okay, now let's come back to this matrix. If you put these vectors in a matrix columns, and if A is invertible, A is invertible, then the set of vectors v1, v2, so on, vn is again linearly independent. Okay, अच्छा, A इन्वर्टेबल है, इसको चेक करने के लिए हम और क्या कर सकते हैं? Some other thing, determinant of A should not be 0. ठीक है, इसके अलावा क्या कह सकते हैं? और बहुत सारी ऑप्शंस हमने पढ़ी थी. If the pivot elements in this matrix A, if the pivot elements in the echelon form of this matrix A, number of pivot elements is equal to n, means is equal to the order of this matrix, then again we can say that the set of these vectors is linearly independent. I hope you remember this thing. Okay, another thing, if we try to reduce this A matrix into reduced echelon form, and it's been converted into the identity matrix, again A is invertible in the context of echelon forms. I'm telling you. I hope you get it. So this is all about the linear independence, linear combinations. If you have any question, you can ask me. Now I'm giving you an example, and you have to do it yourself. Example. Can we write W as a linear combination of the vectors v1, v2, v3, where W is -1, 1, 19, v1 is 1, -1, 0, v2 is 3, 2, 1, and v3 is 0, 1, 4. Okay, what do we do? Is there any question in the chat window? 1:20, what time is the quiz? Okay, we have a couple of minutes. Now, how to check whether we can write W as a linear combination of V1, V2, V3? So what you do here, you write W is equal to some unknown constants K1, V1 plus K2, V2 plus K3, V3. Okay. Now, you put the values of V1, V2, V3. Okay. अगर हम can, if I ask you, can we write W as a linear combination of the vectors this one, then you don't need to write this kind of non-homogeneous linear system. What you do, you just put these vectors in the columns of a matrix, you check the determinant. If the determinant non-zero, then we say that we can write W as a linear combination of V1, V2, V3. This is the simplest method. But if I say write W as a linear combination of this, then you have to write this expression and you have to find the values of K. Okay, now W is what? It is -1, 1, 9, 9 या 19 है, जो भी है. K times what? 1 minus 1, 0. K1 times K2 times 3 to 1 plus K3 times 0, 1, 4. Okay. Now this is what? This is a non-homogeneous linear system. What? K1, and you can write. Basically, if you want to solve it, you can write augmented matrix. Augmented matrix क्या होगा? A, B and A. इसके जो column vectors होंगे वो यहाँ पे आ जाएंगे 1, -1, 0, 3, 2, 1 and 0, 1, 4, and the right hand side vector is -1, 1, 19. Okay, now you convert it into echelon or reduced echelon form, जो भी आपने करना है. You find the values of K1, K2 and K3. Okay, if these values exist, then you can check by putting these values here in this expression or in this expression and solve this side. If you get the right hand side here, you can say that we can write B as a linear combination of the vectors V1, V2, so on, V1, V2, V3. Is there any question? Quiz के लिए 40 minutes हैं आपके पास. If you have any question related to linear combinations, linear independence, linear dependence, you can ask me any question. Otherwise, let's start the quiz of today.